So how do you solve quadratics using square roots? First, we've already spent 6 weeks talking about how to solve by factoring using factored form. So as a quick review of that technique, when we have factored form, we have this structure. We have two factors that are equal to 0. And you learn that to solve from this position, you set each factor equal to 0. So here I can say x minus 1 equals 0. So I could say x minus 1 equals 0, or I could say x plus 4 equals 0. And each of these factors will produce a solution or a root of this quadratic. So if I solve this quickly here, I can add 1 to both sides. And I can find that one of my solutions will be x equals to 1, or in this other case I can subtract 4 and find that x equals to negative 4. So we learned that we can solve by factoring from factored form. And here I can find that my roots are going to be 1 and negative 4. The goal for today's notes, though, is different. Now we're going to talk about a different method or technique to do this. So you want to solve by taking square roots. Now, the way that this looks structurally, guys, this only works when you have no bx term. So to be very clear, this only is a usable technique when there's no bx term. If there is a bx term, then this is not going to work. You can't use this to solve your quadratic. So the steps are going to be pretty straightforward. First, let your equation equal to 0, and you want to get x squared isolated by itself. Next, you're going to take the square root of both sides, and then you're going to interpret the result. Because remember, when you take the square root, you have to put a plus or minus every time. So with that being said, let's try example E here. So here's my equation. First, I'll let the equation equal to 0. So 0 equals x squared minus 4. Now I want to solve this equation, so I'm going to have to move things around. First, to move this negative 4 over to the left, I'm going to use the opposite. So I'm going to use a plus 4 to cancel that negative 4. So that's gone. And I have 4 equals x squared. The moment that x squared is isolated, now I can get rid of the square. And we learned that the opposite of a square is a square root. So now I can take the square root of both sides. And guys, when this happens, two things occur. One, the square root will cancel the square, so x comes out by itself. And secondly, you have to always put a plus or minus when you take a square root when you solve an equation. Once that's done, now just interpret this. So the square root of 4, we know is a perfect square. That's going to equal to 2. So in this example, I've now solved the equation by taking square roots. X equals plus 2 and minus 2. Guys, as a connection, look at the graph of this same parabola. Do you see how we solved to get plus and minus 2? Well, look at your graph. Do you see how you have plus 2 as an x-intercept and minus 2? So don't forget, as we move along and solve quadratics, keep making the connections from the equation to the graph. When you find these solutions or roots, you have to think of the picture in your head that when you graph the same parabola, you're going to have those x-intercepts at those same values. Guys, to finish briefly real quick, to make another connection, again here now to factoring, if we look at the exact same problem, and instead of solving by taking square roots, I factor it, look at what happens here. So again, let it equal to 0. Guys, at this point, if you can see in this example, this quadratic, if I look at it again structurally, is going to be the difference of squares. See how it's x times x, and then here 2 times 2. So you could have also solved this quadratic by factoring. Do you see? Now you have choice. So I could have factored this quickly by doing x plus 2, x minus 2 equals 0. And then I could have also found from here that x equals to minus 2 and plus 2. Do you see? So guys, the point is, as we get deeper into quadratics, you're going to have different methods to solve. You have to have the skill to decide which technique do I want to use. Right now on the screen, you see 3 of them. You can solve by graphing, you can solve by taking square roots or by factoring. But each of these have their limitations. So to repeat, factoring, remember, does not always work. So not everything is factorable. Taking square roots does not always work. If there's a bx term, you cannot use this. And then for graphing, it could be imprecise if your x-intercepts fall in between your integers.